Have you given yesterday's AtCoder contest?
Yes.
Okay. Let's discuss the first three questions today. First question, it is told that we have to give a password which will be at least of length L. So there are few test cases like it should be 5. So it is greater than equal to 5, then it will have to print yes. 3, then it is 2, that's why it's no. How you have solved? Can you share your approach?
Yes, it is very easy one. Uh, we will check the length of the string. If it's lesser than the s, then we will say yes. Otherwise, no.
Okay. Yes, it is the easier one. So we have taken a string s and the length n. So if it is greater than equal to n string length, then we will print yes. Otherwise, we will print no. Okay. So let's move to the next question. This question says that there are n cities, and we are given the distance between the cities uh, of an with an array of n minus 1 size, like this input we are given, and we have to print the distance between all other cities. Like, let me explain this. There are 5 cities. So suppose there are 5 cities, and distance between them are given. Like first and second city distance is 5. Second and third it is 10. We have to print the distance between all other cities, means all the cities, like it is the distance between from first to second, then first to third the distance is 15, then like this first to the fourth one the distance is 17, and from first to the last one the distance is 20. We have to print it in the first line, then in the second line from second city the distance of the third city is 10, and from second to fourth the distance is 12, and from second to the last one the distance is 15. Like this, from 3 to 4 it is 2, and from 3 to 5 it is 5, and from 4 to 3 it is 3. Have you understood the question? How you have solved it? Can you share the
Uh,
approaches?
I solved this with using prefix sum,
Hmm.
taking nested loop, and in first loop, uh, uh, so like I take nested loop, and in second loop, I am subtracting the j element to ith element, and this will give the output.
Yes, I have also done the same thing. Like I have taken an array of n size and initialized it to 0, and I have taken the input and I have done the prefix sum. Then I have done I have subtracted the I minus 1 element from that prefix sum, then it will print that. Like I have taken this array, I have initialized the first element as 0 and take the prefix sum, then we will have this one. Then we will print first this part, then I will subtract 5 from the rest and I will print this part. So this will come, and from this 2 I will subtract then this element 10, then we will get 2 and 5, and from 5 I am subtracting the first element 2 and I am getting 3, right? So here it is done, this part, like the I minus 1 element is getting subtracted. Okay, any doubt? Okay. This is the third question. Black intervals. Uh, we have initially a white painted array, and we will give an uh, array A where we will specify the index of that element, and we have to flip the color. Like if it was previously white, then it will be changed into black. If it was black, then it will be turned into white, right? And in each query, we have to print how many black interval are present. Like initially, we have a array of 5 and we have 7 queries. First two means two which was white turned black, that's why only one black interval it is printing one. Then 3, so 2 3 combinedly will from a single interval, right? So that's why it is staying one only. Then 3 is getting changed to white again, so there is only 2 which will be black. Like, let me write this. So initially we have all white. Then in the first query, only 2 is getting converted to black. So there is only one interval which is consisting of black element. So we have to print 1, right? That's why the first output is 1. Then 3 is getting turned to black. This is 1 only. That's why one interval of black. That's why 1. Then again 3 is getting turned to white. Same 1 will be the output. Then 5. So we have now two interval, here 1 and this is 2. That's why we have to print 2. Then 1 is getting converted, so this will be again black. So this continuous black 1 and this is the second one. And again 5 is getting converted, so only one interval will be there, 1. Then 2 is also changed to white, 1, right? So can you share the approach how it could be solved?
Yes, I take a vector of booleans, and in which false represent black element, white element, and the true represent white element. And we will be taking for each query, if uh, the color of previous and next element of that is black, we will subtract uh, the count, and if it is white, then we will increase the count. Mm, that way, for this.
Okay. So basically, you can tell where the count is getting incremented and where it is not getting incremented, the cases.
When the like if the query, like this, the place I am standing, if it is white and previous element is black and next element is black, if we flip the white to black, it will decrease the counter, and inversely opposite for other
Okay.
option.
So if we have like this condition, we have two elements, right? And if it this is getting converted to 1, then it is changing, reducing count by 1 because it is forming a single interval. And another case could have been occurred that everything was 0 and it changed into 1, so it is increasing the count. So where count is not increased, like if 1 0 and another one, another could be like if it is 1, then it is getting changed to 0. It is not affecting the count, right? So if it is 1, 0 and 1, and it is 0, and it is getting converted into 1, it is also not affecting the count. So count is only getting affected when either it is surrounded by ones in both sides or surrounded by 0. So I have also coded in a similar way. Like I have initialized 0, which will represent the white interval. So I am taking the input x, then if the previous and the next element, if it was white only, then interval will increase if we are turning it into black. But if it was black, like if it was black and we are turning it into a black, then interval is decreasing, right? Because previously it was two interval, but now we are merging that to form a single interval. That's why the interval is getting reduced in this case and getting increased in the other case where it is surrounded by both white. So similarly, the reverse conditions are for white one. Like if we are turning it into white, if it is surrounded by black, then interval will increase, and if it is surrounded by two white, then we are merging that interval, so interval is getting reduced, right? Is it clear now? Okay. Now we will discuss the code forces questions.
So basically, how many of you guys have attended this code forces round? That was
I attended there.
hello.
Yes, we I attended.
Acha, how many questions have you solved?
First two questions.
Okay, very good. Then we will start. Let's read the first question. So basically, the first question that states that a square, a square of rectangles. Okay. Then what is said? Aryan is an ardent lover of squares. Okay, but a hater of rectangles. Yes, he knows all squares are rectangles, but Harshit likes to mess with Aryan. Okay, so basically, Aryan, that is a player, is wants everything to be square. Okay, and he hates the rectangles, and Harshit wants to mess with it. So again, Harshit gives Aryan three rectangles of size L1 into B1, L2 into B2, and L3 and B3, where L and L are the length and B is the breadth of the rectangle. Okay, and it is given that the length and breadth will be given in such a manner that L3 should be always lesser than or equal to L2, and L2 should be always lesser than equal to L1, and same will be applicable for the breadth, as the B3 should be less than equal to B2, and same as B2 should be less than equal to B1. Aryan, in the order to defeat Harshit, decides to arrange these three rectangles to form a square such that no two rectangles overlap and the rectangles are aligned along edges. Okay, so what he wants to do? Okay, so Aryan wants to do. He will arrange these three given uh, three given rectangles in such a manner that they will not overlap on each other, but they will form a square. Okay, and it is given that rotating rectangles is not allowed. So you cannot rotate the rectangles. You have to put the rectangles in such that manner uh, as it is given, as it is length and breadth. Okay, so now we have to tell that if he can or Aryan can defeat Harshit, or if Aryan can make the square with these three rectangles. Okay, so can you share me your approach?
Bhaiya, from the two test cases, I draw it in copy, and uh, I observe two patterns, and based on this, that uh, uh, I solve the question.
Okay.
First one is like L1 equal to L2 and L2 equal to L3.
Mm.
L1 equal to side. Like all lengths are equal and that is equal to side. Uh,
Yes.
and on that case, B1 plus B2 plus B3 equal to side. We will return true. And that will be same for if L1 convert to B2. Like same for like B1 equal to B2 and B2 equal to B3 and B1 equal to side and L1
Oh.
plus L2 plus L3 equal to side. We will be returning same true. And one case is also present like if uh, L1 equal to L1 L2 plus L3
Mm.
and B2 equal to B3. Uh, that will also give 1. So we will be using it also with B1. Like changing L1 to B1, we will getting same answer.
Okay. Uh, so now we will start. Uh, so basically now we will see that what we are given. Okay. So so here it is said that we will be given that L1 B1, L2 B2, L3 B3. These three pairs. Okay. So now, if these three pairs are given, there is a condition that L3 should be always less than equal to L2 and less than equal to L1, and B3 same as will be less than equal to B2, and B2 should be less than equal to B1. So what does it actually means? If we visualize it as the picture, then we can say that if let's say the third number rectangle that is consisting of L3 and V3. Let's say it is size of this. Okay. So what can be the second rectangle? The possibility of second rectangle size. Okay. That is L2 and V2. So it at the minimum chance it may be same as the third rectangle. Okay. That its length and breadth both are same as third rectangle, or at maximum it can be of any length or any breadth greater than equal to this third. Okay, so let's say now we can see that it can be as much big as this. Okay, and as much small as this. Okay, so there is no upper bound for the second up to this, because we have not defined the first one. So up to this, there is a something a lower bound, that is the third, the length and breadth of the third box. Okay, and it can be as small as but it can be more uh, in size, uh, as we have not defined the first box yet. Okay, so what can be the first box size? Okay, if now we see the first box, then it can be as small as the second. Okay, because there is again this the condition that L2 uh, may be greater, L2 is less than and equal to L1, and B2 is less than equal to B1. Okay, so what it can be at the smallest possible case, it can be as the same length and breadth as the second. Okay, let's say it is L2 B2, so it can be as L2 and B2 at the minimum size case, and at the maximum it what it can be. Okay, so as it is the last we can say last rectangle, so it can be as large as much possible. Okay, there is no upper bound in the for the first case box. Okay, let's say it is L3 and B3. So what we can say, we can say that uh, there is no lower bound of size for third, but there is a upper bound, that is L2 B2. For second case, that is a lower bound and upper bound, that is for the lower bound is the length and breadth of third box, and upper bound is of the first box. And for the first box, same to same, that is key, it's there is a lower bound only, that is the length and breadth of second box. Okay, so what can be the possible combinations of putting them together uh, alongside with their edges such that they make a square? Okay, so how can we make? Let's say there can be three possible cases. Okay, so what are these? This can be this. Let's say this plus this plus this. That this is the first box. This is the second. This is the third. Okay, that is their length L. They are all are same, but the B, that is the breadth, these are different, but uh, in addition of them they make a square. Okay, so what we see that it is L1 L2 L3, you can say this is B1 B2 B3. Okay, this can be one possibility. And what is the second possibility? The second possibility will be this, uh, this and this, that their breadth are same for all. Let's say it is B1 for all, and but their length are different. Okay, so first for first it is L1, for second it is L2, for third it is L3. Okay, so and the last possible case that can be, it is that it, this is the first box, this is the second box, and this is the third box. Okay, so this is the last possible combination, how we can make the how we can arrange the boxes. Okay, so we will find how why we are getting or letting the first box as the up of this. You can say that they can be in up of this also. Okay, or they can be a second box, and under this there can be first box and third box also, but it is not possible. Okay, why not possible? Because we know here that one is the upper bound for second box and third box both. Okay, so no box can be greater than first box. So first box, as it is the greatest or the biggest box, so we will just put every other box alongside its edges. Okay, because it will hold the major and the most of the area. So what will be the conditions that these scenarios will happen? So if we see for the first condition, what it is, that L1 equals to L2 equals to L3. Okay, and what, and uh, B2 plus B3 plus B1, that should be L1, as it it must be a square. And what, and yes, so uh, is this sufficient, that L1 equals to L2 equals to L3, and B2 plus B3 plus B1 equals to L for this condition only? Can you verify? Okay, hello, are you listening?
Yes, yeah, yes.
So is it okay, or we are missing something?
Mm, it is okay.
Yes, so it is okay. So what will be the next condition for this? Can you tell me? It will be same for this. Just
Yeah, same. Only B will be changing to L.
Okay, yes.
Then
So you will be changing to L. So B1 will be B2 and B3, and L1 equal to, sorry, L1 plus L2 plus L3 should be equals to B1. Okay. So now there is a trickier part, that is the last condition or the last scenario, that how we can arrange this thing. Okay. So how we can arrange this thing? So there can be two possible cases. Okay. So the first possible cases, first is that we are arranging it in the bottom side, that is second and third. There, but there can be alongside another case. Let me draw that we are arranging it beside it. Okay, so these are the two possible cases. So let's say it is L1, sorry, so it will be B1 actually, B1 L1, and it is L2 L3, and B2 B3. Okay, and let's say it will be L1 B1, now it is L2 L3, and this is B2, and this is B3. Okay, so what will be condition here? Okay, so if we look into this matter with concentration, so we will see that it will only be possible when the B1 equals to L1 plus L2, because this the total length now will be L1 plus L2. Okay, and the B1, that is the breadth, that will be the whole breadth of the total area. Okay, so it must hold to form a square. Now what it should be, that the L2 must be equals to L3. Why? Because if L2 is not equals to L3, then what will happen? Then if it is smaller or greater, then this box, that is this box, it will become smaller or bigger. Okay, so now it is, if it is smaller than this or it is bigger than this, so what will happen? It will not form a perfect square. Okay, so what we have to do, we have to make sure that L2 is equals to L3 always. Okay, and the third condition, what is the third condition will be that the breadth, that is the B1, that must be equals to the summation of the two other breadths. Okay, because if it is not, then let's say B1 plus B2 is greater than or is less than equals to B1, then what it will be? Then it will be either shrink or it will be either inflate. So either of this, if it happens, then it will not be a perfect square anymore. Okay, so again same will be for this condition. So can you tell me the what will be the conditions for this case? Hello, can you hear me? Okay, so just then in that case we will just replace the L by B. Okay, so what it will look like? It will look like that L1 must be equals to B1 plus B2, and B2 must be equals to B3, and L1 must be equals to uh, L2 plus L3. Okay, so these are our four conditions, or you can say the four scenarios in which it can be made as a square. Okay, so out of this there is no possible condition or no possible scenarios where we can make a perfect square from these three rectangles. You can try if you want to, but it is the last. Okay, so what are now in our hand? What are the conditions here? So our first condition is this, our second condition is this, our third condition is this, and our fourth condition is this. Okay, so we will take input as the pairs, and we will check these four conditions If any of them is true, then we can be sure is that Aryan wins, or he can make the perfect square. Okay. So now, if we see the code, uh, so basically, this is the code here. I think you can see. Uh, there what I have done, I have just taken the inputs, that is I have taken the vector as a pair of vector. So I have taken the input, and now then I have sorted. Because I actually, there is no need of sorted, because it is already sorted in reverse order, but I have sorted for my okay. So as, because I thought it will be more convenient, so I just sorted. There is no need of sorting. And if you do not want to sort, then what you will do, you will just flip the positions of positions of 0 with the 2. Where there will look the 0, there we just you just put 2, and where you look the 2, you just put 0. Okay. And rest of them will be same. So what is that, now we will calculate, or we will check these four conditions which I have written for you. That is the first condition. That what was that? That was key L1 equals to L2 equals to L3. That should be okay. So this is that L1 equals to L2 equals to L3. And second will sorry, and with that it was written that B2 plus B3 plus B1 should be L1, and this is it. And same will be for the second case, the conditions, and the third case conditions, and as well as the fourth case conditions. Okay. So this I have stored in the boolean variable, and if any of them is true, then this if statement will be true and it will print yes, otherwise it will print no. Okay. So it will give you the correct answer. So I think there should not be any problem. If any query you have, so you can raise your hand and tell that. Is there any doubt? Okay. So now we will move to the second question. So this is the second question. So what it says that Aryan and Harshit are playing pool in universe AX 120 on a fixed square pool table of side S with pockets at its four corners. Okay. The corners are situated at 0, 0, 0, S, S, 0, and S, S. So basically, the all the pockets, they're situated at the corners. Okay. In this game variation, n identical balls are placed on the table with integral coordinates such that no ball lies on the edge or corner of the table. Then they are all simultaneously shoot at 10 to the power 100 units per second speed, or you can say infinite speed, only at 45-degree angle with axis. Okay. So the angle of the shooting should be of 45 degree with their axis. Okay. So in universe AX 120, balls and pockets are almost point size, and collisions are elastic. So okay, what it says that all the balls and the pockets are point size. Okay, and the collision are elastic. So there is no energy loss between them, and if there is a collision, both the ball will be bounced back as with same velocity, or you can say exchanged velocity. Okay. uh, then the ball on hitting any surface bounces off at the same angle with the same speed. So if it hits any of the wall, it bounces with the same angle and same speed. Okay, so now Harshit shot the ball and he provided Aryan with the ball's position and angles at which he shot them. Help Aryan determine the number of balls potted into the pockets by Harshit. Okay. So it is so now what we have to do, we will be given the coordinates of the ball, the positions of the balls at the first or the at the initialization. Okay, so and we have to tell that after you can say after Harshit makes the move or he shoots the ball, which balls will go to the pocket. Okay, so it is guaranteed that multiple collisions do not occur at the same moment and position. Okay, so it is also prohibited that there will be no collisions with more than two balls at the same position. Okay, so now this is the first input case, that is the visualization of it. Uh, have anyone tried this?
Yes, we I have solved.
Okay, so just tell me in short that what was your approach?
Approach was simple. If the ball is present in the diagonal and the
Hmm.
direction is towards the like uh, corners, it will be uh, like it will be go to that corner. Otherwise, it will not go to the goal post.
Okay, so now we will see that. Okay, so basically, what we are given with, we are given a square table. Okay, so its length and breadth are same. Let's say its size is S, so it is the length of S and breadth of S. There are pockets at the corners. Okay, these are the pockets, and we have said that the balls, they can be kept at any of the point here. Let's say that the ball is any ball of the ball there, it is kept at it there, and any other is there and there and there and there. But it is said that the position of the balls, that is x comma y, the values of x and y must be integral. Okay, so it cannot be possible that you can say that x is 3.5 or 3.7 something. It is not possible. X and y both are both will be the integral value. Okay, and the ball can be positioned at any of the point in the for square table, but it is said that it cannot be positioned at the corners, okay, where the pockets exist, because then it will be directly go into the pockets. So now if we see that what Harshit will do, Harshit will shoot the balls with the if with let's say like infinite speed, because 10 to the power 100, it is more the speed you can imagine. So now what will happen, uh, either the ball, that is it, let's say it is x its axis. Okay, so it always be shooted at by 45-degree angle. Okay, so what this 45-degree angle means, that it can be shooted as this. Okay, there it makes 45-degree 45-degree, and it can be also be shooted like this. There also makes this 45-45. Also it can be shooted like this, 45-45, and also can be shooted like this. Okay, 45 and 45. So any of the balls can be shooted in these four, any of the four manners. Okay, so and how it will be shooted, it will be said to you, as you can see in the question, that it will be given as input that dx dy xi and yi. Okay, so here xi and yi are the integral uh, position points of that you can say ball, and dx dy represents the type of shooting, or how the shooting is held. Is it in that direction, or this direction, or this direction, or this direction? Okay, so now if we want how we can see that how we can read that in which direction we have to read. So if it is the direction, then it will be dx and dy will be 1 comma 1. if it is the direction, then dx and dy will be -1 comma -1. If it is the direction, then dx comma dy, that will be you can say 1 comma -1. And if it is the direction, then it will be -1 comma 1. Okay, so now we have to see that which balls will go to the pocket and which will not. Okay, so if we see that, so basically if you see or observe this thing, that if any of the ball that it is that is not aligned with the corners of the square. Okay, what are the corners of the square? That is the line joining the opposite points of the squares. Okay, so if it is not aligned with the uh, corner lines of the square, and as well as if it is not aligned, then uh, what type of the you can say the shooting we do, it will never go into the pocket. How can we be so assured about that? So if we see its trajectory by shooting, let's say it is shooted at 45 degree at this. Okay, so it is shooted at this. So what it will be do, it will collide here, and as it is a elastic collision, so what it will do again, it will be go here, and again what it will be do, now it will go there. Okay, in this direction, now it will go there in this direction, and now it will be back again at its point. And now as it has there is no energy loss and it has infinite speed, so it will be traveling in this path whole of its lifetime. Okay, so same for all other balls that are positioned not aligned with this uh, lines, that is the corner lines. Okay, so if the first condition, if the balls are not positioned or aligned with the corner lines, then there is no possibility whether what can be the uh, their shooting speed or direction, it will not go into the pockets. Okay, is it clear? You can try another balls by keeping them in other sides or under other positions, but it will definitely will not go into the pockets. Okay, now if we see that uh, it is at the if it is at this point, okay, that is alongside or aligned with the corner line. Okay, now can we guarantee that it will go to the pocket? So how we can be so assured that it will obviously go to the pockets? So in which pockets it can go? So we know that its motion trajectory will be like this or this or this or this. Okay, so if we look at the trajectories, so we can see that only in this trajectory and this trajectory it can go at the pocket. Okay, and if it takes either of this trajectory or this trajectory, it will not go to the pocket, it will just follow this path, that is the same as I have shown you. And so either of this uh, you can say launching direction will not be effectable. So only in what condition it will go to the pockets, that if it is alongside with this line. Okay, and its direction is uh, either at this either at this upper side pocket or the lower side pocket, or you can say the direction of the launching should be same as or the alongside with the corner line. Okay, so same will be for this corner line also. If we keep any ball there, so only this direction and this direction will make it to the pockets. Okay, and either if we do the launching at this or this direction, it will not go in the pocket because it will again let's say it will be uh, moving in this trajectory again. Okay, so what, now we have the conditions. If we see, now we have the conditions that if there is a ball that is given with this uh, dx, dy, xi and yi, these specifications, then what are the must uh, do conditions for which we will get that the ball will be potted into the pockets. Okay, so firstly, that xi and yi, that is the position, initial position of the ball, it must align with the corner, you can say the corner lines. Okay, so what is the condition that it is aligned with corner line? So can you say, anyone, you what is the condition that it will align with any of these corners?
And dx equal to dy,
Yes.
and
No, no. Dx and dy, not x and y. These are the coordinates. So, what will be the condition on them, that it will always lie on either this line or this line? It is given that the size or the of the square is s. Okay.
two conditions. First is xi equal to yi, and second is xi
Yes.
plus yi equal to s.
Yes. So these are the two conditions for which it will be aligned with the either of the two, you can say, uh, corner lines. Okay, so now we get that it can be potted into the pockets, but we are not sure again. Okay, so to be sure again, what we have to do, we have to check that if it is aligned, if the launching direction is aligned with the corner line. Okay, so how we can see this? So if we see xi equals to yi, this condition, so what is this? It is this corner line. Okay, this corner line it is. So for this corner line, what are the you can say launching positions or the launching directions for which it will be aligned with the corner line? So it will be obviously 1 comma 1 either, or minus 1 comma minus 1. For what? For dx and dy. Okay, so in, if either of these satisfies, it will definitely go into the pocket. For this also, what will be the condition? Can you tell me?
1 minus 1 and minus 1 1.
Yes, 1 minus 1 or minus 1 1. If either of these thing satisfies, it will definitely go into the pocket. So we have our conditions, all the conditions. The first condition is this, and the second condition is this, and then after this line we have to check again that if either of these conditions satisfies, or if either of these conditions satisfies, it will be definitely ported into the pocket. Okay, so I think it is clear now. Now if we see the code of it, it will be more clear to you. Mm. So this is the problem B. uh, Sorry, this is your submission. Okay, this is the solution. So what I have done here, I have taken the input, that is the n and s, where n is the number of balls and s are the uh, size, or you can say length of the square. Okay, so now what I have do, I have initialized the answer variable, and then I have taken the input of dx, dy, xy, and I have checked these two conditions. Okay, what I have told you, that x must be equals to y, and dx into dy must be equals to 1. It is nothing but same as that I have said, that dx and dy, the pair should be 1 1 or minus 1 comma minus 1. Okay, this, that condition and this condition, these are same. So don't worry about it. If you like or write like that, it will also be right. And same as the second condition, that x plus y must be equal to s. and dx plus dx into dy must be equals to -1. Okay, and if this condition holds true, then we will just increase or increment our answer variable, and at last we have our answer in our answer variable, and we will just print out it. Okay, and it runs correctly. You can try and check, and I think there is no problem in the B question B. If there is any query or problem, you can just ask me, or I will. Okay, so we will continue to the last question. Okay, the that is okay. So if we read the question, so what it tells that is the question name is divine tree. Okay, so what it says, Harshit attained enlightenment in competitive programming by training under a divine tree. A divine tree is a rooted tree. So what does the rooted tree means? There is a star here. So remember that whenever you encounter a star like that, it is if you will remember that there will always be an explanation about that phrase or that word in at this point. Okay, so there is the explanation what that the rooted tree means. So basically if we read it, a tree is a connected graph without cycles. Okay, you know that. And a root tree is a tree where one vertex is special and called the root. Okay, so what is a rooted tree? So rooted tree means that must be something a special node that can be called as root. Okay, so now if we continue our reading with n nodes labeled from 1 to n. Okay, so the divineness of a node V, denoted as dv, is defined as the smallest node level on the unique simple path from the root to the node V. Okay, so what is the divine energy, or the divine divineness of a path? That is the smallest uh, node encountered in the path between the given node and the root. Okay, so now what I have to do, Aryan being a hungry competitive programmer asked Harshit to pass on the knowledge. Harshit agreed on the condition that Aryan would be given two positive integers n and m, and he had to construct a divine tree with n nodes such that the total divineness of tree, that is m, will it will be m. Okay, so the summation of bi must be equals to n. If no such tree exists, Aryan must report that it is impossible. Okay, so why this so and we have to do it. Okay, so what is said that we have to check if we can make a tree where the divineness, the total divineness, the summation of it must be equals to m, and if it is possible or not. If it is possible, so we have to give the tree as the output. Okay, so this is the sample input and outputs. Okay, so have you tried this question?
No, भैया.
Okay, you have so you have not tried. Then uh, if I check, uh,
Like I read the question but didn't get any approach.
okay, so it is not the tough like, but are some observations that you have to do must to find that. Okay, so we will start just in 2 seconds. Give me 2 seconds. Just okay. So now we will start. So basically, what we have to do, we will be given two things, that is the n and the m. What we have to make, we have to make a tree that will be consisting of n nodes, and that the divineness of it must be equals to m. Okay, so and what we have said, the divineness, that is something called, you can say, the minimum value of the node that will be encountered at the path of that, of the given node and the root node. Okay, so let's say we are given with n equals to 4. Okay, so and if it is n equals to 4, the tree can be look like this. If we consider 1 as the root value, so it can be look like this: 1 and 2, 3 and 4, or any other possible combinations can be true. Okay, so can you just see, or can you just calculate that what is the possible you can say the variation, or what is the possible scenario where we can get the minimum possible value of divineness. Okay, so what will be the minimum possible value of divineness? That will be if we see for this case only, can you say that how can we get the minimum possible divineness, that is the summation dv, and what will be that?
But how we calculate dimensions? I didn't
Minus how we calculate,
know.
just see, for this case, you have to start from this node, that is the root node. You have to go all the nodes, all the possible nodes, and in that path you have to take the minimum number there. Okay, so let's say 1. Okay, so for first case we have to go 1 to 1, so it is just a self loop. So in that case there is only one node, that is 1. So here the divineness d1 equals to 1. Okay, so again we go to 2, node 2. Okay, so if we go to node 2, then which node we encounter, that is 1 and 2. What is the minimum of them? The minimum of them is 1, so again the d2 will be 1. So again we go to 1, we have to calculate d3, that is we will go root node, that is 1 2 3. So what will be the calculation? The nodes that encountered in that path, that is 1 and 3. So what is the minimum of them? That is 1. So here d3 will be 1. So again the last d4, what is that? That is we will traverse from the root, that is 1, to the node 4. Okay, so in that case which nodes we traverse? That is 1, 3 and 4. And what is the minimum of them? The minimum is 1. So d4 is 1. So total sum of d v, what will be that? It will be 4. Okay, is it clear? So if I give you another example, can you tell me what will be the divineness of this? Just calculate and tell me the divineness of this, so I
Okay,
can
dear.
understood.
7, dear.
Huh?
7.
7 na. So if we again calculate and check, so for the first case self loop, that will be 3 plus 4 3 to 2, that will be 2, plus 3 to 1, that will be 1, plus 3 to 4, that will be again 1. So that will be 7. Okay, perfect. So now can you say in what scenario, or how can we keep this tree that it will produce the minimum divineness, and what will be the value of the minimum divineness?
If we set the root to be minimum,
Yes,
then it will.
yes, it is okay. So we have to keep the root as the minimum to make sure that we have we will get the minimum number of divineness for each of the traversal, because in each of the traversal the root will be the integral part of the uh, path. Okay, so now how can we make the tree now? We can make in many you can say So many orders such as that: one, 2, 3, 4, or 1, 2, 3, 4, or 1, 2, 3, 4, and many other types. But all of these, they will produce the minimum divineness, that is 4. Okay. But what we will do, we have to start with a certain structure. Okay. So what we want, that we want that there must be a single structure for in which we have to manipulate it to make our uh, desired m value. Okay. So how we will do it, we have to see it by observation. Okay. So now we will try one by one which of the structure give us the convenient way to make all the possible m values. Okay. So let's take the first uh, type, that is the linear type of the tree. That if we see there, mm, how, so what is the divineness of it? Again, say that. Just
4.
okay. 4. So do can you tell me how we can make the divineness total, divineness 4 to 5? We have to make it 5. Okay. How we can make?
By taking element 2, not 3 to other side,
3 to
left side.
left side na, matlab we you want that we should 3 place 3 as there and 2 as front, that, or
No,
anything else?
no, left of 1, left of root 1.
Left of 1. Okay, so you want to make 3 as the root. Okay. Yes.
No, no, no. I want to insert 3 to left node of 1.
Acha. Okay, so you want to insert 3 at the left node of 1. Okay. So that will make this thing na, that will make 2 and 4. But we don't want this. We want that the structure must be kept intact, because then if the structure is not kept intact, so for each of the cases you have to calculate differently, and you have to make different trees na, that will be hectic for you. So just check for this structure. Just think like swapping, by swapping which of the
Yes,
number or which of the nodes
yeah,
you.
we can make root equal to 2, then it will give 5.
What?
We can make root of the tree to 2, then it will give 5.
uh, you are saying that it must be what?
Like swap the value of 1 to 2.
Yes, so we have to swap these two values. Okay. If we swap
Yes,
this, so we will get 2, 1, and again 3, and again 4. Okay. So now we will get the total divineness dv, that is 5. Sorry, that is 5. Okay. So it is clear now how we are doing that. So again,
yes, yeah.
so tell me that how you can make it to 6 by swapping. Now check again.
Uh, Swapping 1 with 3 on previous tree.
On this tree, we have to swap 1 with 3. Okay. Are you sure?
Uh, mm, Wait 1 second.
Check just you, if you do something by yourself, then you will understand that what is happening. Okay. Or if you don't want, then I will make you see by doing that.
No, no, it will give the answer.
If you want hint, so I can tell you that you just see this tree only. You can also make this tree to be as divine as 6. by swapping any of the values. Which are the two values?
Yes, we are. We can swap one with three in the current tree.
One with three.
Yes.
Are you sure? So if we make one and three swap, what we will get? We will get 2 plus 2 plus 1 plus 1. So makes 6. Okay. So you are right. Okay. So now again, how we can make 6 to 7? Again, check this tree only. Just think that what you have done previously. First, you have swapped this and this to get 5. Then you have swapped this and this to get 6. Now, what will be your swapping? Which will be swapping now? By intuition or observation, you can see.
Last two swap.
So now we will swap the last two. Okay. So what we will get? 2, 3, 4, and 1. Okay. So again we have get the 7. Now we want to get 8. What we want to do? Which of this here now? Which of this will be swapped?
Yeah, we can swap. Uh, we can make a tree with four root equal to 4 and then 3 to 1. No, it will
Yes.
give 7.
So basically, you are right. What you are doing, that is also right. But it will go into another direction, and you will go another. You can say formula. But what formula I discovered in that question, that is for this case. Just follow me and observe the thing that what I am doing, and you will get the intuition. So basically, what I will do here. So in the first case, to make the divineness 4 to 5, we have swapped this and this. Okay, it is okay. So now to make the divineness to 6, what I will do, I will again swap the first element with the second element now. Because previously I have swapped the first with the second element. Now I have to swap the first with the third element. Okay, is there any problem? If we
No,
do that, if we do that
no.
now, if we see, it will make that thing the same thing that I want. Okay, so its divideness is 5. You can also calculate. Sorry, I think 3, 1,
Six.
1.
It is 6.
Sorry, 6. Okay, so I think I had done a small mistake. Let me recheck my calculations. Swap. Okay, 1 to 2. So basically, as we are making swaps, we can take it as an array also, or consider as an array. Let it is 1, 2, 3, and 4 initially, and it is the root. And so what we are doing, we are just let's say we have to increase 5 to 6. Sorry, 4 to 5. Okay, So, oh, sorry. We are doing the right. We are making the six also again, because we have to make six now. This gives us five, so we have to make six now. So it will be right. Three,
Yes, yes.
one, two, and four. This will be given giving six again. So it is confirmed. So what I have done, I have now swapped this and this. So again, to increase by again one, or you can say making seven. What I will do, I will swap now first and the last. Okay. So if I do that, that will be four, one, two, and three. Okay. So now you can calculate it. The dividendness will come as the seven. Okay. So now what I will do, if I want that it must I can increase it again by one. Okay, that I want to make it 7 to 8. What I will do, I now, as I have done all the swaps with the first position. Okay, because at the first all this thing I have done swaps with only the first. So now we will just increase this pointer to one, that is this. So now I will start swapping with this element to all that is down or downside of that node. Okay, so for increase of one, what I will do, I will just swap these two. Okay, so what I will make, 4, 2, 1, and 3, and here we will get 1. Same as a, to make 8 as 9, what I will do, can you tell me what?
Yes, yeah. I will be swapping 2 with 3.
Yes, 2 with 3. So now if we see it as a array, that is 1, 2, 3, 4. Can you tell me, are you observing something that is familiar with some swapping, or that is the array operation? How can we make the thing happen?
We can use nested for loop.
Yes, nested for. And what we will do?
We will be swapping with like J element, I to J.
Yes. So let's say there is I for the first instance. So and the first instance of j is this. So j must be equals to I plus 1, and we will start swapping with the index I index. And when the swapping is done for first index, and if we see that we need to increase more, then I will just increment this first pointer to this, and continue the same nested loop for again and again until and unless we are getting our answer. Okay.
Yes, yes.
Yeah, okay. So now we have to see that what is the maximum value that we can achieve by this. Can you say it for this thing? One,
Maximum
that's one,
value.
two, four.
It
What is the
will
maximum value of dividendness we can achieve?
8, I guess.
What?
8.
8? No, no. We I have just make you 9 na. I have showed that how I
Yes,
can
yes.
make it 9.
So, 9.
Just see this. Okay, just see the first thing that we have made. Okay, this. So how can we make it the maximum? As it is minimum, what will be the maximum? Just try to shift something or reverse it, and then check it, and you will get your answer.
Repeat, you are not able to.
What?
Your sound is lagging there. So repeat.
So I am telling that just do one thing, that this was our first trees. Okay, so just make some shift or some swap or some reverse, and then you will see what is our answer. Okay, what is our maximum dividendness?
Yeah, it is 10 there.
Huh? 10 na?
10.
Yes. So how you
Yes.
can 10? By what? By doing what? See this thing.
by summing all information of node.
Hello, hello.
Hello?
Am I- yes, yes. You can tell.
Yes, yes.
Can you repeat?
We can calculate by the summation of all nodes.
Yes. So basically, what we are doing, we will reverse all the values. Okay. So we will make 4, 2, 3, 2, 2, 2, 1. Okay. Is this clear?
Yes, yes.
So what if we see a thing that here what will be the type of the division sum? That is, the summation will be 4 for this, and at last this 4 plus 3 plus 2 plus 1, that is 10. So again, for you can say now, can you tell what is the if it is given n, what is the maximum value we can achieve and the minimum value we can achieve? Can you tell me? Here n was 4.
Minimum is 4 and maximum is 2 and plus 2.
What is the minimum again? Can you tell me?
1 second here.
Just see a thing that for n equals to 4, the maximum summation was this, and the minimum summation was this 1 plus 1 plus 1 plus 1, 4 times, and it was something like 1 plus 2 plus up till 4. Can you see something now?
Yes, we have some of values of 1 to n.
Yes. So what now? What will be the minimum possible value and maximum possible value for given n? Can you tell me?
Maximum will be n
Maximum is,
and minimum will be n, sorry. And
yes.
maximum
Minimum
will
is,
be
just see this.
1 plus n by
What? Can you repeat?
1 second.
Okay, actually, you are not audible rightly. Okay, just see me. It is summation of 1 to up to the n. So it will be n into n plus 1 by 2. Is that correct? You can just thumbs up for your reaction if it is okay. So what we have now, we have the minimum possible value and the maximum possible value we can make. Okay, and as well as we have discovered by observation that what we have to do to make anything, or you can say make any number, that is m. Okay, so for the first instance, what we will be having, we will be having an array. Let's say that it will be as 1, 2, 3, and dot 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 up to n. Okay, so as for the given n. Okay, so now what we will do, we will first check that if the given m, if it is greater than n into n plus 1 by 2, or less than n, then it will return -1, because then it will not be possible to make a tree. Okay, and if it is between them, these values, and then what we will do, we have now we have to check that what amount of times we have to increment the value of n, so that it becomes m. Okay, so let's say m is 6 and n is 4. So up to what time we have to increment the n, or that is 4, to make it 6? We have to increment it 2 times. Okay, so the, let's say our increment is m minus n. So that times we have to increment, and for each time for increment by one, what we were doing, we were just swapping the values by the nested loop. That is for nested loop, that is the I was that is I is for 0 index to n minus 1, and j is from I plus 1 to n minus 1. And what we were doing, we were swapping the a of I and a of j, okay, until and unless we are getting our desired answer. That is that what we will do, we will decrease the increment variable, that is the increment, that is m minus n, okay. So we will decrease it in each iteration of and the possible swapping, okay. So now when the increment variable that will become 0, then we will be assured that we have made the same number as we desire. Then we will stop the swapping and we will just break out from the loop, okay. So is this okay for you guys? If any problem, you can say.
Yes, we understood.
Okay. So now if we see the code, so it will be more clear to you. Uh, so this is the code. So again, what I have done, I have taken the input that in and s, and I have taken uh, as an array. Okay, that is a vector of length n, and then I have just put and I have just checked the condition, first condition, that if it doesn't holds true, then it will just return the minus one or print the minus one, and if it doesn't hold true, then it can be possible that we have to make the tree. Okay, so now what we will do, we will just have seen that our structure is a linear structure. Okay, the tree as a tree linear structure, and for that we have make the array to represent it, that is a, and here we will fill our node, the value of nodes, that is 1 2 3 4 up to n, okay. So here I have filled this, and what I have done, this is our increment variable, that is the answer variable. That means that what amount of increment we have to do in n, such that it is s, okay. Because at the initial condition, the divineness of that array, that is the ai, that is the a, that is n, okay. Because we are putting like that 1 2 3 4 in the increasing order. So if we make one as root, and we will and we do same as the thing, and we make the tree as the linear tree 1 2 3 4 up to n, then we will get the divineness at a as n into a 1, that is the n, okay. So we know that for the first initial condition we were getting the summation as n, and now we want to increment it by answer times, okay. So now what do we do? Now we will do the our swapping operations, that is the in the nested loop, that is this. I have said that previously. We will do the outer loop from I equals to 0 to n, uh, n minus 1, sorry, and then the secondary loop or the inner loop, that will go from I plus 1 to n minus 1, okay. And if any of at the time answer variable becomes 0, then we will just break out from the loop, okay, and we will get our answer as a form of the array, okay. So now after all the operations we are getting the array, and what will be the root of the tree, the the element at the first index of the array, that is the a naught or a0, that is our root. I have printed the root here firstly, and then I have printed all the edges for connecting the two nodes, okay, two consecutive nodes. That is printing the two consecutive numbers at a time. That makes you sense that these are connected in the tree, okay. So it is the whole code, and these are the outputs generated by it, and it works very well, I think. uh, if you have any doubt, you can tell me. about this code?
No, we understood.
Okay, so then it is okay. So now our PCD comes to an end. For today, this was our total PCD. That's the three questions of the portfolios and the coders. So you may leave now.
Thank you, Via.